Hello, and welcome to the first Python part of your data visualization lectures. So while we import all of our packages, I just really quickly want to point out that we're using a couple of new packages that we haven't used before. So make sure that you're importing plot9, both the entire package, and specifically we're going to look at the mtcars data. So ggplot is a beautiful way of building plots where essentially you build little parts of your plot one by one and you add them all together to create one big plot. And I really love this kind of Lego block way of building plots because, as I talked about in the previous lecture, I think it really encourages you to be thoughtful about the data visualizations that you're making. Now, I'll go into some of the specifics in a second, but I just kind of want to show you what ggplot can do. So the first thing that I'm going to do is I'm going to use the ggplot function to plot a scatter plot from the mtcars dataset, which we just imported. mtcars is a dataset all about cars, so we're going to plot the weight and the miles per gallon as a scatter plot. So the first thing that we have to do is tell the ggplot function what we want to plot, like in terms of what data frame we want to use. And in this case, we want to use the mtcars data frame. The second thing that we need to tell Python through ggplot is something called the aesthetics of the graph. And this is essentially how you want your data to look when you're making the graph. So in this case, we're going to say our x-axis, we want weight to be on the x-axis. And on the y-axis, we would like to have miles per gallon. Now, this is basically telling ggplot, okay, when you make the plot, I would like weight on the x-axis and mpg on the y-axis. But it's not actually going to do anything yet. In fact, here, I can show you what it would look like. So you can see that it's creating sort of the background and the foundation that we need to make a graph, but it hasn't actually done any data visualization yet. So again, the ggplot function tells ggplot how theoretically to plot your data, like what are you plotting, but it doesn't actually create a graph for you. In order to do that, you have to add something called a geom, and geom stands for like a shape or something, a type of graph that you're going to make. In this case, I want a scatter plot, so I'm going to say geom point, and I'm going to add that literally with a plus sign to the output of the ggplot function. This is going to allow us to not only have the background for our graph, but the actual data plotted in a specific way, in this case as a scatter plot. So now you can see that we just added our points, so now we have a beautiful scatter plot. And as you might predict if you know anything about physics or cars, the heavier that your car is, the less miles per gallon it gets, which makes sense. It takes a lot of energy to move a heavy car. Now, I wish I could teach you literally all of ggplot or plot9 here, but there's just way too much to possibly learn because graphs are basically infinitely customizable. But I do want to show you some common things and how to make some common charts. The first thing that I want to show you is that we can add a trend line or a regression line to our data by using the plus sign again. So remember, we're just kind of Lego brick, like adding features one at a time. And we can do that using something called stat smooth. And we're just going to say method, there we go, equals LM, which basically says add a regression line to your data. Okay, so once we've added that, we can run this and you can see we're going to get a very similar graph to before, but we're adding one new feature, which is this regression line. Awesome. Now we can take this and we can add even more things because again, ggplot is basically Lego bricks for data visualization. We can just keep adding and adding and adding and adding. Let's say that we want to add a different graph. So we want to make one graph per number of gears in the car. We can do that using the facet wrap function by adding it on to our existing ggplot item. And the way that we do this is by giving it a string. We'll say tilde, a little squiggly line, and then the name of the variable that has the groups that we want to make one graph per group. Again, we'll go over facet wrap again at the end of this lecture, but I just want to show you a little bit more about kind of the Lego nature of all of the ggplot graphs. So you can see we got a very similar graph to above, again, MPG on the y-axis and weight on the x-axis, but now the facet wrap function added one graph per number of gears. And finally, there's a lot of cool stuff that you can do inside of ggplot. For instance, I really like the graph we just made, but I think it would be a lot prettier if we had colors. So let's add an argument to our AES function that says color equals, and we'll say, okay, I want a different color for each gear. So I'm going to say factor gear. And factor just means turn this numeric variable, which is 3, 4, 5, into a categorical variable so that it treats 3, 4, and 5 as separate categories instead of as one continuous number. Now, this is basically going to say make the exact same graph that we did before, but for each plot, make it a different color. So when we run that, you can see exactly the same plot as before, but now we have different coloring based on the number of gears. Okay. So let's look at this really cool penguin data set. First, we're going to load in our data, and I went ahead and printed out the first couple of rows just so we know a little bit about the data that we're working with. Let's make just a bunch of graphs. Remember, the first step in building a ggplot graph is telling ggplot what data you want it to use and how. So in this case, we're going to say ggplot. And we're going to say penguin because that's the name of the data frame that we would like it to plot. And then inside this AES function, we're going to tell it what we want it to plot and where. Let's say we want x to equal bill length, there we go, mm. And we want y to be the bill depth, mm. And let's say that we want it to be colored by species. So we'll say color equals species. There we go. So now that we've told ggplot what to plot, let's just run this and see what happens. Okay, it's a blank plot. Remember, all we've done is tell ggplot what data and how we'd like it to use that data, but we haven't actually told it what the shapes and what the actual graph type should be. To do that, we can literally copy and paste what we had before and add a geom. In this case, I think I want to add a scatter plot, so I'm going to use the geom point. And once I run this, we should get a graph that now also has the actual points on our graph. Beautiful. So this is actually really cool. We can see with respect to bill depth and length what the different species of penguins are like. And actually, it looks like they're pretty distinct. There's some overlap, but each species has a very clear profile of what their bills look like. Let's try another graph. This time, I want to think about what the body mass of all of our penguins looks like. So again, the first step is to tell ggplot what data and how you would like it to use that data. We're going to use that by doing the ggplot function. Again, we're going to use the penguin data set. And in AES, I'm going to say, I think that I would like X to be body mass in grams. Now, this time I only have one variable because that's all that I'm interested in. And if you run this, you can see that we get a plot where body mass is on the x-axis, and that's about it. Again, we haven't added a geom or really anything to tell ggplot actually visually how the data should look. It just kind of knows what data it's supposed to plot eventually. If we copy and paste this and then go ahead and add some kind of geom, we can add, let's see, a geom histogram. And this will, as the name suggests, make a histogram for us. So let's go ahead and run that. Beautiful. So now we can see the distribution of all the different body masses of all the penguins in our data set. You can see that most penguins are between 3,000 and 4,000 grams, but we got some pretty hefty boys at one end of our spectrum over here with a 6,000 gram penguin, which is very surprising. All right, let's make another graph. So I know that I have a bunch of different penguin species in my data set, but I'm really interested in knowing how many of each species that we have. I can do that with a bar chart, but first I have to tell ggplot how and what data that I would like it to plot. So I'm going to say ggplot, and I'm going to say, again, like with all of these, penguin, AES, and if I'm interested in the species, I'm going to say x equals species. And when we plot this, it should be a blank plot, right? Because we've only told ggplot what data we want it to use. We've not actually told it exactly how we want it to plot. Let's go ahead and run and see what that looks like. Oh, had a little typo. Let's run it again. Beautiful. So now you can see we do have our species down at the bottom, but a blank graph. If we want to actually add something, we're going to need to add a geom. So let's copy and paste this and go ahead and add our geom. Cool. So since we're working with a categorical variable, I think that I want to add geom bar, because a bar chart will be able to tell me by the vertical distance how many penguins are in each species in our data set. So when I run this, you can see that that's exactly what we get. We get this beautiful bar chart with the number of penguins in each of our different species. We can compare them, we can see how many penguins are in each, all because we did our beautiful ggplot graph. Now that we kind of have an idea that there's different species, I'm kind of interested in what the different bill lengths are for each of our species. We already saw in our scatter plot that they're different, but I'd like to just focus in on bill length and see what it's like for each of our species. So I'm going to tell ggplot that gotta spell that right, that I would like to use the penguin data set and AES. I'm going to say x equals species, which is actually really similar to what we did above, but this time I'm going to say y equals bill length mm. And again, if I run this just by itself, we get an empty graph because we've not told ggplot how we would like our data to be plotted. What I can do here is use a box plot, and a box plot is a great way to display continuous data. Let's go ahead and look what it looks like. Beautiful. Okay, so you can see on the x-axis we still have our different penguin species, and then on the y-axis we have the bill length. So we can see what the different bill lengths are using this box plot. As a review, a box plot, the middle line represents the median. The end of the boxes, both upper and lower, represents the 25th and 75th percentile. And then the little whiskers on your box plot represent the entire spread of most of the data. So we can use this to compare, on average, what the bill length of all of our different species is. For instance, I can see that the chinstrap penguins tend to have the longest bills, and the Adelie penguins tend to have the lowest, and the Gen 2 penguins are somewhere in the middle. The box plot really gives me a good idea of how spread out the bill lengths are within each species. And if you see any data points on top of your box plot, that basically means that data point is an outlier. It's pretty extreme compared to the rest of the data. Now, as I alluded to before, there's a lot of different Lego bricks that you can use with ggplot to change the way that your graph looks. You're not stuck with this basic ggplot default. So let's take the graph that we just made and let's add some color to it. So since we did some box plots, I think it would look really pretty if instead of all of them being white, they were different colors based on the species of penguin. I can do that by using the fill attribute in the AES function, and I can say fill equals factor. Oh, actually, I don't need to factor. It's already a factor. Fill equals species. And so when I run this, we should get the same graph as above, but as you can see, the box plots are now filled with different colors, which just kind of helps our eyes see visually what the difference between them is, even though it's technically the same graph as before. And that's not the only thing we can add. In fact, one of the things that we'll talk about in our next data visualization lecture is all that stuff that I talked about theoretically, how to make effective data visualization. Well, one thing that you can do is make sure that you don't have extra stuff laying around in your graphs. One way that you can do that is with a ggplot theme. A theme is essentially a typical way that you might want your plot to look. And one of my personal favorites is theme_minimal. Again, you can totally see how you're just Lego bricking this ggplot where we just keep adding new features or new themes on top of each other. When we run this, we should get a plot that looks pretty similar to what we saw above, but is in a different theme. And in a second, when you get to see it, I'll talk about why I really like this theme. Okay, so you can see that while the information that is being displayed is exactly the same, we can see aesthetically that there's a lot of differences that actually kind of look better, or at least easier on the eyes. For one, we're getting rid of that gray background. That not only increases the contrast between the information, aka the box plots, and the background of the plot, but it just doesn't waste ink. I know that we don't actually print out plots anymore, or at least we don't do that very often, but why waste ink on information that's not important? A gray background, highly unimportant. We don't need it, so we can get rid of it. And again, I'll talk more about this effective data visualization in the next lecture, but I just wanted to give you an idea of some of the things that we're able to change. One other thing that we can do that is super cool is we can layer geoms. So far, we've just been using one geom at a time. Maybe we're making a box plot, maybe we're making a bar plot, maybe we're making a scatter plot. But you can actually use these geoms in conjunction with one another. Let's go ahead and add actual raw data points to this graph. We can do that by using the geom point function that we've used before. When we run this, you can see that we get the exact same graph, but now we've also overlaid the raw data instead of just having our box plots. One thing you might notice with this plot, if you can see, is that both the box plots and the individual data points are filled with the same color. That's because we set the fill equals species inside the original ggplot function. If we only want an aesthetic to be in one of our geoms once we're layering them, we can actually specify that characteristic inside the specific geom that we'd like it to be. For instance, even though it looks really pretty here, I think I'd like my data points to be black instead of being filled with different colors. I can do that by removing the fill equals species inside the general ggplot function, which will apply that aesthetic to every single geom, and instead just put it inside my box plot function. So I can say AES fill equals species, and when I run this, you're going to be able to see that very similar graph, but if you look closely, all of our data points aren't filled. That's because we set fill equals species specifically for box plot and not for all of the geoms in our graph. So just to review, if you put an aesthetic inside the ggplot function, it applies to every single geom that you add to your graph. If you have a desire to have different aesthetics for different geoms, you can set them directly inside the geom when you add it. So far, we've basically just covered geoms. We did use a little bit of a stat summary at the very beginning, but I quickly want to talk about the stats. So we have geoms, which are different shapes that things can take on, but we also have the option of using stat functions. One of the most common ones that we'll use is something called stat summary. Stat summary is a great way to make things like bar charts that show, instead of the count of things like we did before, maybe the mean. We could have a bar chart, for instance, with the different species and the body mass of each species. Let me show you what I mean. So first we're going to create a ggplot, if I can spell it correctly, plot, and we're going to say use the penguin data. Inside our AES function, we're going to say x equals species and y equals body mass in grams. Now, we don't need to do this, but just so it's pretty, I'm going to say fill equals species, and this will give us different colored bars, one for each species. Now, once we've added that, instead of adding a geom directly, we can use stat summary in order to create our bar chart. What we want to do is tell the stat summary function what summary we would like it to make. Here in fun_data, I'm going to tell it to use mean_SDL. And there's different options that you can have. You can always look up the documentation to see what other options you have, but this gives you the mean for the continuous variable body mass that we're looking at. The other thing that we have to supply to the stat summary function is what kind of geom we want it to use when calculating the mean. And in this case, I think we want to do a bar chart. So let's go ahead and run this and see how it looks. Beautiful. So now we have a bar chart where, unlike the original bar chart we made, where all we were doing was looking at the count, so the number of penguins in each species, in this case, we now have the mean body mass for each species as a bar chart. And we also colored or filled by the different species to get the graph that you see in front of you. Now, I'm not going to go over all of the different things that we can add. I'm going to cover that a lot more in next lecture. But I just want to give you an idea of what we could do with this graph that we just made to make it a lot more aesthetically pleasing and clear in the message that we want to send. So let's go ahead and run this. Beautiful. So you can see there's a lot of similarities with the graph above. I mean, it's plotting the exact same data in the exact same way, but we've made a lot of aesthetic changes that make things a lot clearer. And I think that this is really important and something we're going to talk about in the next lecture, because why include information that's not helpful in communicating the message that you want to communicate? So last thing in this lecture, I promise, we're going to load this data set of cereals from different companies. And let's just make a couple of graphs. I just want to be able to show you a couple of different things that might be interesting and useful to you. So first, let's go ahead and make a simple bar plot. And this time we're going to look at, for the different manufacturers, how many cereals are listed in this data set from that manufacturer. And let's make a couple of fun aesthetic changes to make the graph a little more visually pleasing. First, we're going to do the ggplot function and tell it to use the cereal data set. Cereal, there we go, data set. And let's go ahead and set our AES. So we want our X to be manufacturer. And let's make a bar chart. So we'll say geom bar, and we will go ahead and say AES fill equals MFR. So remember, you can set aesthetics either in the main ggplot function or inside the individual geoms. And just to make it look a little better, let's use theme black and white, so theme BW. That's another favorite of mine. It's very pared down compared to the default. Not as much as theme minimal, but just so you can see what some of the other themes look like. Beautiful. So we have our graph, and you can see on the x-axis we have the different manufacturers and how many cereals they have in this specific data set. Now, I briefly mentioned this before, but I really want to show you facet wrap because it's an incredibly useful function that I think you might find some good uses for when exploring your own data. So let's go ahead and create a new ggplot, use cereal data, and we'll say AES, and we'll say X equals protein, there we go, and Y equals sugar. Because I'm really interested in knowing whether the protein and the sugar in different cereals has a relationship. So we're going to go ahead and plot this as a scatter plot. So we'll say geom point, oops, there we go. So let's go ahead and really quickly just run this. So we get a scatter plot of the number of grams of protein and sugar, and you can see there's not really a clear relationship. At least in the cereals that we have, it's not like the more protein you have, the more sugar you have, or even vice versa. Now, I want to show you the facet wrap function because it's incredibly useful here. Maybe there's no relationship in cereals as a whole, but I'm really interested in knowing whether that relationship holds or not for each manufacturer. If I want to make this specific scatter plot, but only make one for each specific manufacturer instead of all the data as a whole, I can use the facet wrap function to do that. I'm going to say facet underscore wrap, And we're going to give it, again, a tilde, a little squiggly line, and then the name of the variable for which we want to make one plot per level. In this case, it's the manufacturer variable. So when we run this, it's going to make one scatter plot per manufacturer. And just so everything looks a little pretty, I'm going to add theme, BW, in order to clean up some of the little aesthetic things that we don't actually need. Beautiful. So hopefully this makes sense. When we before had just one scatter plot, we now have one scatter plot per manufacturer. Same x-axis, same y-axis, and all of the same aesthetics, but we just have one per manufacturer. That's what facet wrap and its similar function facet grid do. They allow you to create a similar type of plot once for each level of a different variable that you might be interested in. Okay, now that I've totally overwhelmed you with data visualization, I'm going to end the lecture here, and next time we will talk a lot more about that effective data visualization I was talking about. Now that you know the basics, hopefully we can dig a little bit deeper. But we'll see you next time.